how the AI resonates with NSO and the CWM. Welcome, Wei Tai.
Okay, thanks. Oh, so here's the Slido code you just missed. So we're going to be using that towards the end to gather your questions. For those questions that I don't get to, I'll try to address them offline. Okay. Okay.
Have questions, you can just also wave out. I'll hand over the mic.
But save them for the end.
Yes.
Yeah. Okay. Okay. So my name is Wei Tai. I've been working on ConfD and NSO for the last, I don't know, 10, 12 years. I'm currently the product architect working on the Crosswork Workflow Manager, as well as the Crosswork Workflow Manager Solutions. So here's the agenda for today's session. I will try to keep things practical and educational for you. And then as I said earlier, I have time for questions at the end. And my goal for you is to leave this session and be able to use GitHub Copilot effectively to generate the very first working workflow on CWM. So let's talk about some claims made by GitHub Copilot. So that is the tool that I'm going to be using to show you how to do code generation. It boosts productivity. Certainly you can come up with your prompt in one sentence or a few more sentences. And GitHub Copilot will be able to generate an entire program for you, right? And it enhances learning. You can either choose to have GitHub Copilot explain to you the entire program in detail, or just a block of code. That is really a good way to learn how to code. And it accelerates prototyping. This is especially true in the case when you don't have to harden your code, that you can ask GitHub Copilot to generate the code for you that you can get up and running right away. And it increases access to coding. So you no longer need to be a hardcore programmer in order to be able to code to do network automation. And it improves code quality. It's supposed to be able to refactor code for you to make the code either more efficient or more elegant. So I'll revisit these claims again towards the end of my presentation and give you my take on them. So, so how do you access the Copilot chat feature using Visual Studio Code? So you have this chat icon over here in what they call the Visual Studio Code, the activity bar that you can click on and either bring up the chat window, this one over here, or hide it. So that's one way to access it. And there's also a Copilot chat button up here, right next to the search bar, that you can click on, again, to either enable or disable the chat window. And then inside of the editor window, you can also either select a block of code, and then this sparkle icon should come up automatically for you to click on. Then you'll be able to ask questions in this window. And if that sparkle icon doesn't come up, you can, at least in the case of the Mac, you can press the key on the keyboard, Command I, then this ask a Copilot prompt window will then come up. Okay, so this is the list of extensions that I have installed in my Visual Studio Code in order to help me to work on the projects that I will be showing you today. I assume most of you should be familiar with most of the extensions here, maybe except for this one, the KIE Serverless Workflow Editor extension. This is the extension that would help you either create or modify a workflow definition file. So let me give you some background information on network automation. So the CWM workflows, or the Crosswork workflow manager workflows, are used to automate east and westbound integrations, to help with your to help streamline and automate your change management process. And it integrates with either NSO or other controllers through the adapters that either they are pre-built or the ones that you can build yourself to interact with the network devices on the network. You can use it to modify the configuration or perform maintenance tasks on the network devices. So this is the list of technologies that I'll be showing you today in terms of code generation. I'll show you how to, I'll show you how to access the NSO's RESTCONF API through some Python coding, as well as through the workflows. Certainly the Python scripts in conjunction with that. And I'll show you how to generate serverless workflow DSL specification files. And then the JQ expressions. These are the expressions that you would use to perform data manipulation and transformation of the JSON data inside of the workflow. And lastly, Go. This is the language that you would use to code your CWM adapter. So with this question that I have listed on this slide, so for widely used programming languages that have plenty of examples lying around on the internet, on GitHub repositories, those have been used to train large language models, right, that are being used by GitHub Copilot. So in terms of being able to generate the proper code for dealing with those sort of programming languages, isn't much of a challenge for GitHub Copilot. But unfortunately, for those programming languages that are maybe still very new or just recently defined, such as the workflow definition language that has been released, officially released only a short while ago, there are lack of enough examples to train GitHub Copilot on. So I'm sure we'll reach a time that would no longer be a problem. But at least at this stage, there are some additional effort that is required on your side in order to make this possible. So I'll go over some challenges and tips over the next few slides that would help you make good use of GitHub Copilot. So challenges. When it comes to working with the NSO's RESTCONF API, you need to know the YANG paths, right, in order to do what you want. Maybe accessing a particular net, CLI net, accessing a particular YANG model on your device. So you need to figure out the right path. And unfortunately, a lot of those knowledge are lacking in GitHub Copilot. So there are ways to get around that. And then again, back into the workflow DSL syntax. This is something fairly new. So GitHub Copilot hasn't yet been well trained on it. And I've run into a situation that inside of a workflow that got generated by GitHub Copilot, it got mixed up between calling a CWM adapter versus calling a child workflow. That was happening to me quite often in the early days. And then lastly, the mistakes in generating the JQ expressions. But in this case, I found that there are ways to get around that. And in terms of consistencies, meaning being able to get consistent results by giving the same prompt, so language models, the large language models, they are probabilistic in nature, meaning that there are multiple valid outputs for any given input. So the key is to construct precise and unambiguous prompts in order to get the consistent answers or the results. So back on tips on how to make effective use of GitHub Copilot. You can provide the curl, call, and response in your chat, right? When you're working with REST or RESTCONF API. That way, GitHub Copilot has a much better context as to how to generate either the Python script or the workflow for you. And provide example workflow as context in the case when you're working with workflow definition. And ask follow-up questions to refine the results, right? If you notice that maybe the question that you posted was not specific enough, that GitHub Copilot is tangenting off into the weeds, then ask some follow-up questions to steer it back into the right direction. And lastly, use other AI tools, right? Because GitHub Copilot, there are periodic releases, and there are periodic trained models that are being fed into GitHub Copilot. So it's certainly not up to date as we speak. So if you can leverage those AI tools that can make use of internet searches, you can certainly get more updated information. It used to be that Perplexity API was one of the only ones that could leverage performing internet searches to give answers for you, but nowadays even ChatGPT can give you the same capability. So in the world of GPT, when it comes to domain-specific knowledge, it's rather common that people implement this RAG, the retrieval augmented generation, in order to be able to extract the relevant information from a database and add that along to your prompt when your prompt is being input into the GPT system. Now, in the case of using GitHub Copilot, what I've noticed is that you can do something similar manually, meaning that instead of relying on a program to find the relevant information for you, you manually go out and seek out the example in order to get along with the prompt. That way, the GPT would be a lot more effective and would be able to give you the accurate answers or results. So this chart shows you the importance of providing context when you ask GitHub Copilot questions. You see from the chart that providing context is you get the results are double or twice as helpful as when you don't provide context. If you leave the prompt wide open, you can certainly get any possible answers. So the first example that I'm going to show you would be to use Python code to automate the invocation of an NSO RESTCONF API. So this is to retrieve the Exile software version. So I have a prompt down at the bottom that I try to be as specific as I can. That way, the Python script that gets generated would do what I would like it to do. So it generated a function to pose the RESTCONF call into NSO, and then also passes the results. And then the main function just passes the input arguments so that it can make the command line invocation and submit the RESTCONF API call. So I even asked GitHub Copilot to generate the command line invocation. So now I'm saving it into a file, the code that GitHub Copilot generated. And then with the command line invocation, I copy and pasted it onto here. And this is the CLI output that I got back, the software version. Certainly, I could keep on going and try to generate maybe a regular expression or a text FSM template in order to extract the exact software version information, if I like. So my next example is to show you some Go code for a CWM utility function adapter. So this project, I worked on a POC for this project, and this was the project that got me started experimenting or exploring the GitHub Copilot. When I first started working on the POC, I had to learn how to write Golang code in order to be able to write the schema validation adapter. So I was telling myself that wouldn't it be nice if I don't have to learn the syntax, or at least I don't have to memorize or remember it, and be able to write code quickly and come up with the adapter. So after I completed that project, then I started working with GitHub Copilot to see if that is possible. So in order to work on this adapter, so one thing to mention here is that utility function adapters are different from the API adapters that you would write in CWM. API adapters are those that allows you to integrate with external systems. But utility function adapters are typically the ones that would perform data manipulation or transformation for you, right? That you would pass JSON input into the adapter and then get whatever response that you want out of it. So I would use the CWM SDK to generate a skeleton project. And then the activity, you see the activities.go file? This will be the one that has a blank function prototype, right? That you have to fill in with your implementation. So this is where GitHub Copilot comes in. I formulated this prompt. I ask it to use open source library. And then I tell it that the two input that I'm using are JSON objects. I notice that when I don't specify that, it has a tendency to assume that I'm working with string inputs. And then I wanted to generate a string output of the validation results. So this is to validate the input, the workflow data input against the schema. So this was useful back in the time when CWM didn't have this built-in capability. So this is sort of can be deprecated now, but I just show it as an example for you. So this is the code that I got generated by GitHub Copilot. So it's able to pick out an open source library, and it knows how to load the JSON schema and the JSON input into the relevant part of the schemas. It then performs the validate function, which is supported by the open source library, and then generate the results, right? Either the JSON document is valid or the JSON document is invalid. So now that you have the code, you can certainly test it inside the CWM, but then it involves a little bit of a round trip, right? That you have to load the adapter into CWM first. So one way to test it inside of your Visual Studio Code environment is to ask GitHub Copilot to generate a main package for you, or the main function that can be used to exercise or to invoke the validate function. So that's why I have formulated this prompt and ask it to generate the Go program for me. And this is the resulting code. So the test data, both the schema and the input data are hard-coded, as shown here. And this will then set up the request by using those hard-coded data, and then invokes the validate function, and then shows you the results. So in this case, these are the positive test data. You can certainly change it. You can run it once with the positive data, and then run it the second time with the negative data, right? To make sure that it works properly. So let me give you a brief introduction to serverless workflow DSL. I'm sure we have plenty of other sessions that go into that in a lot more detail, but since I'm showing you a demo of how the code, the DSL code is being generated, I think it's good to get some overview ahead of time. So the serverless workflow DSL specification is standardized by the Cloud Native Computing Foundation, and it can be written either in JSON or YAML as defined by the standard. But at the moment, CWM only supports the JSON style. It describes the steps, the conditions, and transitions between tasks within the workflow. And it orchestrates various cloud functions or services without managing the underlying infrastructure, hence the term serverless. So this really simplifies application development, right? And you no longer have to worry about managing the entire infrastructure. So here is a structure of the workflow definition file. If we go from left to right on the slide, you have a bunch of states within each workflow. You have the start state, and then you have the end state, and a bunch of intermediate states. And each state requires some workflow input data to process, and then it generates output data that is then subsequently passed on into the next state. And if you go to the very right-hand side of the slide, this is the definition of a state, that you have action that could be invocation of either an adapter or in a child workflow. And then you can use JQ expressions to filter both the input and the output parameters that are working with the action. And lastly, the transition tells the state when it's done, which state it should transition to. So I have two sets of workflow examples that I'm going to show you. The first one is a CWM Solutions independent kind of workflow that would process an XR OS upgrade via the device's NETCONF interface. And then later on, I'll show you how to use GitHub Copilot to generate workflows to work with the latest CWM Solutions 2.0 release. So here is one example workflow that I have used GitHub Copilot to generate as I was constructing the end-to-end workflows for completing a OS upgrade for XR router. So I'm using this as the reference or as the context of an example workflow. And then I'm giving it prompts as well as the curl, call, and response. So I've given it enough information that there's no longer any ambiguity in terms of getting GitHub Copilot to generate the right workflow. So you see the scroll bar. So now it should be completed. So I'm going to insert the generated workflow into a new file in the editor window. So you see the first block is the first state handles populating the RESTCONF API call. And then the rest of the states just handles taking care of the sort of whether it's success or fail from the RESTCONF API call. Now, then the next example I'm going to show you is the JQ expression code generation. This one is probably not too readable for you. So this is a case when I need to compare the interface summary results that are captured during both the pre-check and the post-check. And I am including this as a payload. And then I'm asking GitHub Copilot to generate a JQ expression for me that will compare the differences between the two. So the result that I got back was very close to working, except for one error. So you see the results that I get back here. This is the error message that I got. This is the error message that I got. And I was able to feed that error message back into GitHub Copilot. And then GitHub Copilot was able to fix its own error and gave me a corrected version of the JQ expression. So I think this comes really handy, except that you do have to spend a little bit of extra effort to get it to do everything correctly. So I only show you one case of the workflow that I've generated. So this is a sample run of the XR OS upgrade workflows using the NETCONF interface. And this is the UI screen back in the 1.0 release that we had a prototype UI that we had used to show workflows. So it shows you that I have a parent level workflow that's called the invoke XR upgrade. And then I invoke some pre-checks and then some post-checks here. And then in the middle, the actual upgrade operation. So as you can see here, the image op copy activity does not require any polling because it's a synchronous operation. It's a synchronous NETCONF operation. And then the other two, the install, replace, and the commit, those are asynchronous. That's why you need to insert a workflow here that will do the polling in order to determine that it has run to completion. So now let me move on to show you an example. So you're going to be seeing demos over the next 2 days on the latest solutions that we have released with the that we will be releasing soon with the CWM Solutions 2.0 in the fleet upgrade use case. That we have now a UI that would help you generate a map workflow that allows you to pick and choose what pre-checks and post-checks that you want to include in that map. And we have a list of pre-built pre-checks and post-checks that allows you to choose from in your UI. And in those cases, when you have to add your own, then you have to write the workflows in order to make it to be something selectable by the map builder UI. So I'll show you something really simple here. I'll show you the show run hostname map activity workflow. The run is just a short abbreviation for running config. So here I will show you. So this is the very simple workflow example that comes out of the box from our CWM Solutions. And I'm using that as a context. And as you can see, this is the navigator output of the workflow. And I'm going to bring up the prompt. This is the prompt that I'm going to be enter into GitHub Copilot with the CLI output as well as the sample JSON output. That way, GitHub Copilot would know how to generate the JQ expressions to process those JSON outputs. So this is the reference workflow. And now I'm pasting the prompt down here. And then GitHub Copilot is now in action. And it generated what is called the capture hostname workflow for you. So you see the bar going, it's still generating. When it's done, I will insert this into a file on the editor window. That you see it actually generated a text FSM template that will be passed inside of the CWM structure, infrastructure to process that text FSM template. So I'm saving it into a file, and that should be, yep. And then this is the NSO call, and then this processes the results from the NSO call and determine the end state, whether the operation has succeeded or not. And again, you probably want to test it before you load it into CWM, right? So I could ask GitHub Copilot to generate some test code for me in Python to test the text FSN template that it generated. So I've selected the template over here. And I'm going to type in the prompt window here to generate a text FSN template with the string IO library. So here's the generated code. I'll insert it into the editor window. Give it a name so that I can run it. And then one thing I noticed here is that this value over here should be right next to that triple double quote. Otherwise, it would flag as an error. So now I'm getting ready to test it. So it passed out the host name correctly, so telling me that the text FSM template is working properly. Then now this is a sample run of just the workflow. When I loaded that workflow into CWM, this is the input and that's the output. It shows me the host name and then the message and then the status. And in order to make this workflow to be selectable by the map builder UI, that's part of the CWM Solutions 2.0 release, I have to add all these tags into this workflow tag field. So you have this app fleet upgrade that tells the fleet upgrade solution that this workflow belongs as a map activity workflow. And then the rest of the product series that is being supported by the workflow. So once I do that, I'll show you how I can now select this new map activity workflow that I just added into his own map. So now I'm creating a map. I'm populating the necessary information to generate the map. And then notice here that when I do a sync actions, it changed from 22 to 23. And then it added the capture hostname workflow that I've just added to the system. I'm going to give it a custom name and select the stage to be pretest, and then add it, and then create a map. And I'm going to run a fleet upgrade. So you have to enter all the necessary information. In this case, I have to select an image, select the name of the map, give the job name, and you see now that job is running. I can select it to track its progress. So over here, the first time I clicked it, it's still being executed. I refresh it. Then this is going to show that the hostname extraction succeeded. That is the same message that I showed you earlier. So that's how it goes. I think the second examples, I don't have enough time, but I'll briefly touch on why I came up with the second example. The first one, I use a very simple workflow, and it has the same kind of states. They're very similar to what I have in mind to process the mob activity workflow that I wanted Copilot to generate. The second one, I use a much more complex workflow that I only needed a subset of the states. In that case, the prompts that I had to come up with is a lot more elaborate. I have to tell GitHub Copilot to only use the states that are relevant to the workflow that I would like it to generate. So I'll skip all those. So conclusion. So key takeaways: provide context, be precise and unambiguous in your chats. And I believe the AI-assisted code generation can be helpful when you follow the tips that I have provided over here. And then just like any kind of code that you even write yourself, or the ones that's being code generated, that you still need to test it, right? And as far as the claims, my take on them, I would agree that these 4 bullets I'm in complete agreement with. As for the last one, I just didn't have experience to try it out, so I can't speak to that. But the rest, I would agree with. So this is the list of resources that you can take away, and hopefully you can figure out how to effectively use GitHub Copilot to write your first workflow. So I guess I have a little bit more than 3 minutes for questions.
Any questions?
Go ahead.
Will this presentation somewhere available publicly?
It will be, yes.
Will be, okay,
Yeah.
Thank you.
Mm-hmm. Anyone else?
Have you tried to use this Copilot to generate a complete NSO package?
Complete
NSO package.
NSO package. I have not tried that.
You think it could be possible?
I think it can be done, but again, you probably have to provide more context. And also with the updated documentation that is now available on the internet, I assume at some point, the LLMs that are being used by GitHub Copilot would get caught up, and it should be able to use those information. Yeah.
Thank you. More questions?
Any questions on Slido? No. Okay.
Okay. Thank you very much. Thank
Okay.
you, Wai.
Thank you.